The Global Positioning System, or GPS, is a ubiquitous source of timing for critical communications infrastructure. Mobile networks use Global Navigation Satellite System, or GNSS reference timing, to synchronize frequencies in 2G, 3G, LTE, and more recent 4G LTE advanced technologies. As these network operations become more and more dependent upon precise timing and synchronization, the vulnerabilities of the GPS and other satellite systems is of growing concern. The results from a 9-month study conducted by the U.S. Department of Defense recently indicated that an outage of 12% would impact approximately 4.5% of the United States. Some of the more common vulnerabilities that GPS systems are exposed to include jamming and spoofing, equipment failure and interference, environmental impacts, and errors inherent in space-based systems. In their simplest form, jammers transmit a relatively powerful noise signal, typically RF, that crosses GNSS frequencies, thereby causing receivers to lose their lock on the satellite signal. Spoofing is slightly more complicated. Instead of simply drowning out the GPS signal with noise, spoofers substitute a counterfeit signal with altered data. In a spoofing technique known as meaconing, GNSS signals are recorded and then broadcasted on the same frequency, but the timing information is no longer accurate. Equipment failure and interference can be noticed in several forms. Antennas and cables are sometimes subject to breakage. In addition, nearby electronic equipment can malfunction or degrade and radiate energy that interferes with the GPS signal. Towers themselves are also prone to damage over time. Small cell equipment is prone to damage too, especially since many new base station solutions are deployed in non-traditional locations within the network. Environmental impacts represent additional forms of vulnerability to GPS. Lightning strikes or high winds can often take out antennas. Sleet and ice can freeze over the antenna and impair its ability to receive the signal. Solar flares are bursts of energy from the sun, which result in an increase in the radiation that can temporarily impact the GPS signals and cause errors in timing signals. There are several sources of error inherent in space-based systems that can impact the accuracy of the calculations. They include satellite orbit error, satellite clock error, ionosphere and troposphere delay, multipath, and receiver noise. In North America and throughout the world, GPS outages occur, and when they do, the implications are often very serious. A recent example of an outage occurred on January 26, 2016, when one of the satellites was removed from the constellation, resulting in a GPS signal anomaly. Most of the users having a holdover raised concerns, but were not affected by this anomaly. The two most common means to protect against a GNSS outage include the use of a high-quality holdover oscillator or reliance on a network-based backup signal. For critical timing infrastructure, it is recommended to use a rubidium atomic clock for the best holdover protection. A second option is to address the loss or impairment of GNSS signals is known as network distributed time. This consists of a GNSS primary reference incorporated into a time server or a grandmaster clock. From here, time-stamped packets are distributed via a timing protocol to clients or slaves embedded in the equipment at other locations in the packet network. Network distributed time can also provide backup against other sources of timing disruption, such as simple equipment failure or human error. Timing and synchronization are more critical now than ever as service providers continue to evolve their networks and operations. Vulnerabilities within current and planned GNSS systems have caused governments and network operators to carefully consider solutions that mitigate the impact of GNSS impairments and outages. The solutions mentioned here have their own advantages and challenges with respect to technical feasibility and cost. Please get in touch with your microsemi partner to learn more about how you can protect your network against GPS vulnerabilities. Microsemi provides a complete solution set to protect network disruption for the 24/7, 365-day world we live in. For more information, please visit www.microsemi.com.